learn, derive continuity equation, that is the Laplacian operator that I have shown you, del square h divided by del x square plus del square y divided by h divided by del y square plus del square h divided by del z square is equal to 0. How it is? So to do that, this is basically the continuity equation in our ground order flow regime. So let me derive that. That will help you to understand in detail how this water flow is occurring in a given situation. Start drawing. So here this is a block, and this is a cuboidal block. Drawing is not good in that respect. There is a flow is there in this direction and some amount of in this direction. Similarly, flow in this direction, flow out in this direction. Some flow this particular shape about this particular. So this is y-axis. This is x-axis. This is z-axis. Okay. Now, if the flow in this direction is Vx, so flow Vx is in the x direction. Okay. Out is Vx plus del Vx divided by del x. Del x. Similarly, in this direction was y. So the amount of flow will occur in this direction. It will be rho y plus del y by del y del y. Similarly, for the z is in a z, the out would be z plus del z del z delta z. So this is understood. Means we are now trying to calculate some amount of water is flow is entering into this block. In this block, we will analyze everything. And amount of flow is exiting. There is a in, there is a out. There is a in, there is a out. In this direction, in this direction as well as in this direction. So in and out, difference between these two is basically the gain of in this block. Is understood?
Sir, your cursor is not
Everybody?
moving, sir.
Huh?
Your cursor is not moving, sir. In which direction we are not able to see, sir?
Okay. This x direction, the in, this amount of flow is in, means let in inside this block. This amount is flow out. Okay. So net gain, difference between these two is a net gain in this block, in this direction, x direction.
Okay, sir.
Understood? Similarly
Yes, sir.
for the z, this is a in this block, in the z direction. This is a out in this block. So difference between these two is a net gain in the z direction. Similarly for the y, this is an in amount and this is an out amount, exit amount, and difference between these two is a net gain in the y direction. So summing up x direction, y direction and z direction is the net gain of this block in three different directions. It is understood?
Yes, sir.
So basically this is a flow. This is a basically elementary control volume. It's called control volume. Let me save this image, then it will be helpful to me. This is in volume. Now uh, we start a new one. So for the earlier case, if we call the earlier one, we call the earlier one. I will put that image later. So on the x del y and del z face, because this was a block. Okay. So this basically is basically del z. Okay. This basically del y. Okay. So in x direction, I am meaning this is the x direction because this is a z, this is y, and this is x. So x direction flow is occurring through this del z and z or del y phase. So on this phase, the flow will be rho x because this is in del y del z, okay, minus rho v x plus del v x divided by del x del x. This was the original expression into del y del z. Is understood? Because we are only multiplying with that earlier volume into this square area. of this surface. Okay. Similarly for Tarun, it is understood? Sarun, it is understood, Tarun?
Ah, yes, sir.
Okay. So this will be, we summarize it will coming minus del OVX, okay, divided by del X, okay, del X, del Y, del Z. Similarly for del X and del Y face, this is a del X, this is a del X, okay, and del Y, this is a del Y, this is a del Y. Basically it indicates this phase basically, okay, this phase is indicating in the bottom direction, so upward flow. In this phase it would be equals to minus del O E Z, because in this flow del V Z divided by del Z del X del Y del Z. Similarly for del Z and del X phase. What is del Z and del X phase? Del Z is this and del X is this. So in this phase, what is the net flow? It's basically minus del, this is it is a y direction, so y divided by del y del X del Y del Z. Now it is understood? Everybody it is clear? Everybody it is clear?
Yes, sir.
A little bit, sir.
Tell me what is your question?
Now, if you have the material, show it to me and I will see. Then I will ask you.
Okay, we will continue and you just pour over the material and then you will ask. Okay.
Yeah, yeah.
So now, then if I save it, yes, should be inward flow or a mass flow rate. Mass rate. This is there. Now I take a new phase. The new phase is basically the total mass flow. Total mass flow mass inflow actually. Total mass inflow per unit time. What would be the total inflow? Is basically equals to minus, okay, minus del OVX divided by del X multiplied by del X del Y delta Z. Okay, minus del O Y divided by del Y del X Ly del z minus del z by del x y del z. Okay. So gathering all this term and passing the differential will be like this: minus del x x plus del y del z. In this case, I should use bracket. Okay. Bracket is essential. Divided by del z x y z. Okay. So this is the total mass inflow in that block. Okay, per unit time. So what is the total mass then? Total mass equal to rho del x del y. Mass change with unit time with as pressure change d dm dt plus x y z del p difference with time. This will be required when we want to express a mass equilibrium is achieved. Okay. Now equate this mass flow rate to mass B. It will come same as mass with change of pressure. It is so. Then it will be equal mass flow amount is basically would be minus the earlier one del x del x plus del y plus del rho z z x y. Now change in mass it is observed that rho should be multiplied by alpha plus beta phi to dx y z gamma h by why this is so? Because it is observed that del P divided by del T is equal to gamma H divided by T. Based on this assumption, we are changing to this. So the mass flow will come if we take into this account. It will be come around minus L x Lx plus 5 plus del z z multiplied by mu is coming outside dx dy is equal to rho alpha plus of 5 dx dy z gamma dx series mass flow rate in terms of pressure rate. So again mu, then it will come basically minus del equal to plus in the bracket del y del y plus z z is basically coming y plus the y h okay, minus if it is so, then substitute Darcy's law E is equal to k h by dt or k del h. Can substitute this b value, the Darcy's equation. Then the basic equation will come like this: kx del square h del x square plus y ky del square h del y square plus kz del square h del y square equal to gamma plus w h del h. So if it is so, then uh, if you can understand that if it is a homogeneous, it is a homogeneous, and isotropic plus isotropic. It is a homogeneous and isotropic. What will happen? This kx is equal to ky is equal to kz. Is it? If it is a homogeneous and isotropic, it should be kx is equal to ky is equal to kz. Then we can represent it as now if I delete that above term, I think now it will come like this: k into del square H divided by del x square plus del square H divided by del y square by del square H divided by del square is equal to, basically it will come S, storage index that we have studied, del H divided by storage index of that particular. So for a 2D flow, it would be KB. Suppose for a z direction, it is the flow we are measuring. So del square H by del x square plus del square H divided by del y square is equal to S into B del H del B. For a 3D, it is for a 3D it is, for a 2D it is. Okay. So these basically, if we take this term, this basically indicates the total flow and the total storage, net amount of storage in that particular case.
Hey,
What happening? Anything? Gabriel, are you asking something? So continue that. So it is basically for a 2D flow, this particular expression can be written as, rewritten as, divided by this KB. This K will come and we can read this. So what is happening for this particular case, that if if it is observed the net flow is total, this, this particular amount is 0, and we know this K cannot be 0 because there is a hydraulic conductivity value. So this particular expression will finally be saved as, saved it otherwise. This expression del square H del x square square H del y square del square is equal to 0. Basically, this is called Laplacian operator. This is called Laplacian operator. So this is what we want to understand, this Laplacian operator for the means. So this is equal to 0, and this equation we will use. This equation we will use time to time when there is a requirement to use the flow net. Now let me start that expression, how to draw the flow net and the rest of the things. In the flow net, so this is what we have tried to reduce the expression of the Laplacian form that we will time to time use in all the plot for plotting the stereo, not stereo net, flow net. In the flow net, in the initial discussion, we have told you that flow net basically have a property. Uh, in a condition, it is a steady state, flow, and in a steady state flow, velocity is not very high. And this Laplacian operator can also be written as, Laplacian operator can also be written as, this Laplacian operator can also be written as del square H. In this form also, this delta operator is basically removing this h. This is del square h is the general expression for the Laplacian operator. So this expression we will use time to time whenever it is required to understand into details, greater details of the problem. So this is about the first part of today's lecture. Now in the second part, we want to calculate how is basically h in a head, in a confined aquifer. Head is basically independent of a. That is, we are going to reduce for our case. So in that case, in the flow net, there is a boundary condition in a flow net. There is a boundary condition. There is initial condition, and there are equation to be solved, and that equation will solve like this. This equation will solve like this. So the equation will solve basically del uh, del x and k is dx plus for a 2D. Okay, for a 2D, we can do, oh, this is kx, this is ky. So this is basically we can calculate. So if there is a no flow, there is a no flow, it is zero. Okay, there is a no flow boundary, then del h by del no flow boundary in n direction, then it would be zero. That indicates there is no flow in that n direction. Okay, h is a constant. Now in this condition, we will try to maintain few things in the flow net. Few things is basically uh, the potential, uh, the equipotential line, potential line and flow line. Flow line is mutually perpendicular to each other. Is mutually perpendicular to each other. Okay, and no flow line will intersect with each other. Okay, no flow line will intersect with each other. That things we have to maintain. That things we have to maintain. So this is about the flow net, how to draw that, and using that, now let's take a problem. Let's take a problem. So in this problem, we'll try to
Sir,
understand.
this is
Tell me.
sir, this is perpendicular. I think only in case of homogeneous and isotropic, na sir.
We have already assumed. That is why from that we are calculated it is homogeneous and isotropic.
Okay, sir. Okay.
Okay. Yes, that is that should be considered. So this flow is basically perpendicular to equipotential line everywhere, and flow line will never intersect each other. And the area between the flow lines is basically uh, will form a curvilinear kind of square, curvilinear line of square, and in another way, it is square. Okay. So that square we are going to measure dimension of those squares. So in those square you can accommodate a circle. You can accommodate a circle, and the greatest diameter of the circle you can determine from that particular. So these basically looks like we plot we plot plot like this. A given condition, the flow line, flow line. So you can accommodate circle over it. Okay, so you can determine the highest diameter of that circle it is going to accommodate. Okay. Based on that, you can determine the dimension, the width is the width, or you can calculate the dm, perpendicular distance, m, and this is the horizontal ds. So based on that, you can calculate other one also here, the del dh by ds, because s is the distance here, this is the distance here, it can be written as kdh, kdh. Okay, k is the hydraulic permeability, conductivity of that particular. So if it is q, can also be written like this, small m, kdm. So based on that, we can also calculate here. Uh, here the q is basically the number of lines, number of flow lines we have. Okay, that we have to give a nomenclature. How many flow lines is there? Which flow line, and how many potential difference is there? Okay. So in our case, for a system, one recharge area, one discharge area, we can calculate the discharge if we take this help. This Q is basically equal to Q uh, N F into K. K is the hydraulic conductivity. K. So K is the hydraulic conductivity, and DH the head difference. This is the uh, formula. We can use it, or you can also use it. H is equal to ND into BH, because number of total head difference is number of head difference, ND, and head difference, individual head difference, and number ND, number of drops is there. So total head is this H, and this is the number of flow lines NF, and KDH is the flow. KDH is the flow. So total number of flow, this number of channel is there. So multiply this. So total flow is this. So in that way, we can calculate the flow line in a, in a homogeneous and isotropic. So this can be rewritten as, for a homogeneous and isotropic, transform it, and we can measure accordingly. Take a problem so that you can determine in your home how to do that. Problem is this. Now take a problem. H is the head, H2 is the head. Problem. Suppose this is a telephone, and to observe there is a h height, and you assume any dimension. You assume any dimension, and you should assume NF at least five number of channels. NF you should assume. ND you should assume at least 3 to 4 number of edge difference. Calculate. Now, based on this calculation, I request you take the assignment. This will be three number home assignment it is, or two. Arun?
Sir, I think it is three, sir. Mansi insisted on also exactly. I missed some of the classes in the middle.
Yeah. So, the number of floor lines you should assume at least 5, and number of head difference you should assume 4, and based on that, there is a head difference h. You can take a value of h any like 20 meter. Okay. You can assume that 20 meter head difference, and based on that, assume other parameter whatever necessary. Draw the flow nets and calculate the total flow. So uh, total flow should also give you the value, because in that case it will help you to calculate. So you can take that Q value. Let me calculate that, then I will give you the value of Q. Okay. Based on that calculation, I will give you the value Q. Then you will take this assignment to solve 7-day time. Next week.
Sir, this one will be assignment number 4.
No, this is 3. Earlier was homework.
Sir, second assignment was means calculating shear on inclined plane, and third was that means we have to plot that phi internal friction angle
No,
and.
that is home. That is homework. That is not assignment.
Okay, sir.
So
So,
this Q value I will calculate. I will calculate this Q value. Then I will give you. Let me take this assignment and then we will discuss. Okay. Now, this is I am saving it. Number. I will mail you this picture so that you can get it. So this is about the flow net and the diagram that is required time to time discussion. So let me first ask you one by one question, because many new things we have introduced today. So we should proceed slowly, that everything is understood by everybody. So let's start from Ajay, Ashish, Gabriel, Haritaru, and Mansi, and Sanjeev and Satyam. So please raise one by one your questions so that we can clarify and we can proceed. Ajay,
हाँ yes sir.
any question you have?
No sir, it's clear.
Ashish,
No, sir.
Gabriel,
No, sir.
Haritharun,
No, sir.
Mansi, Mansi, Sanjeev,
Sir, for now it is clear. Then, sir, I have some doubt regarding calculation of sharing on an inclined plane.
okay. You show me your calculation. Share the screen. I can discuss.
So actually, I did it on page. So yet means the calculation is not over. I did some part of it, and then I got some
Can you
confusion.
show? Can you show in the screen so that I can discuss that? Okay, I can clear the doubt.
Okay, sir, it is not in my laptop. I just do it on paper. I'll have to scan it, and then I'll have to do
So
it.
what you will do? You let me take a time in some time, and you can discuss in video conferencing. Okay.
Okay, sir. I'll mail you, sir. After. Okay. Thank you, sir.
Ramraj, Samraj.
Clear, sir. Everything is clear, sir.
Okay, thank you very much. So you will proceed